Alright, so 2023. So what we are going to do, we are going to locate repeat questions. And if you all want to see the solutions for them, you all will have to go back in the previous videos and watch them. But really watch the videos from the later years come up the road. So for this particular question, the derivative of this would have been, I believe, minus 1/3. 1 over 3x. Number 2, given that z is equal to minus 1 plus root 3, the exponential form of the complex number is, so we're going to get tan inverse of root 3 to give me tan inverse of root 3 is 60 degrees. That is pi on 3. And this complex number is minus 1 plus 3 is over here. So it's pi minus pi on 3, which is 2 pi on 3. The answer is D. This is a repeat, ln cot x. The derivative is going to be minus sec x cos x. Given that f of x is 3x squared, is that f dash minus 2? Yes, it is f dash minus 2. So we will differentiate the function to get 6x and divide it back by the original function, which is 3x squared. So 3 goes into this 2 times. 1 of the x cancels with 1 of the x. So we get 2 over x. 2 over minus 2 is going to be minus 1. This as well is a repeat question. I believe the inside brackets, the inside square brackets is 8i squared. Sorry, 8i multiplied by the I is 8i squared, which is minus 8. The principal value of the argument of the complex number is, this one would have been a 3 pi on 4, because tan inverse of 1 is pi on 4. And this complex number is minus 2 plus, which is here. So it's pi minus pi on 4, which is 3 pi on 4. This, yet again, is another repeat question. The answer for this would have been B. Yet another repeat question. I can't remember what the answer for this one is, but let me go through it, right? It's easy to solve for y in this case. So x cubed y is equal to 3 minus 6x. Y is equal to, divide by x cubed, are going to get 3x to the minus 3. Take away 6 over x cubed will be 6x over x cubed is 6 over x squared. So we get in 6x to the power minus 2. Differentiate it, we're going to get minus 9x to the power minus 4 and plus 12x to the power minus 3. When x is 1, I'll get minus 9 here, plus 12. The answer for this is 3. The second derivative is minus 1 on x squared, but we'll still go through it. Differentiate the function, we get 2. Divided back by the function, we get 2x. So we get 1 on x. That is x to the minus 1. And I differentiate this to get minus x to the minus 2, which is equal to minus 1 on x squared. This one is another repeat question, and let me just go ahead and do the working for it just in case. It is going to be a tan inverse. This is 1 over 1 plus, I need to change 9x squared to be 3x all squared. When I differentiate the 3x, I'm going to get 3. That going on the numerator, and I had to put the third in front to compensate. So this is going to be equal to a third tan inverse of 3x plus c. A third tan inverse 3x plus c. The answer for this is B. The derivative of cos cubed x is, we're going to get cosine x all cubed. When I differentiate, I'm going to get 3 into cosine x squared multiplied by sine x, negative sine x, sorry. I'm going to get 3 cos squared x minus 3 cos squared x sine x. So the only one that has a minus is a. This is a repeat question, but we will still go through it. If I'm not mistaken, this is also a unit 1 question. If cos 2x is this, we want to get the integral of sine squared x on 4. So all I'm doing is I change in x to be x on 4. So I'll get cosine 2 into x on 4 is 1 minus 2 sine squared x on 4. Rearrange. I'm going to get sine squared x over 4 is equal to, u and u cancel to be 2, 1 minus cosine of x over 2. And I have to divide everything by 2. Divide this by 2, divide this by 2. So when I integrate sine squared x on 4, I'm now thinking I could have used a substitution there, but regardless, we already reach here. So when I integrate a half, again a half x, take away. When I integrate cosine, I'm going to get sine. So I'm going to get minus sine x over 2 divided by 2. And I need to divide by the differential of the angle. So I'll divide this by a half, which is being multiplied by 2. So the 2 and the 2 cancels. And this is evaluated between pi and 0. When I plug in 0, again 0, when I plug in pi, I'm going to get pi on 2, take away. Sine of pi on 2 is 1, so pi on 2 take away 1 is my answer. So hopefully this one comes exactly like this. Just make sure it's sine squared x on 4 and not cos squared x on 4. And the limits are the same. You get your answer. This again is a repeat question. If I'm not mistaken, this is going to be minus 2e to the minus x into x plus 1. This one is also a repeat question. This one, it was 3/4, I think. 2x plus 2y dy dx is equal to 0. So dy dx is equal to minus 2x over 2y, which is minus x on y, minus 3 over minus 4, which is 3/4. Yes, I was correct. In the chemical reaction, we know we want to get the integral of 1 over a minus s into b minus s. And the only one that gives us that is this. The value of this is from 1 to 5. We could go and add up all. I think this was 1023. If I'm not mistaken. But let me go ahead and write out each of the terms. So this is 3 multiplied by 4 to the power of 0 plus 3 multiplied by 4 to the 1 plus 3 by 4 squared plus 3 by 4 cubed plus 3 multiplied by 4 to the power of 4. So we have first term, second term, third term, fourth term, fifth term. We are going to get 4 to the power 0 is 1. So 1 plus 4 squared plus 4 cubed plus 4 to the power 4 multiplied by 3 is 1023. Yep. Number 17. Which of the following converges? This is a repeat. This is the only one that will converge. The value of this is going to be a over 1 minus r. A is 1 and r is x. So a over 1 minus r is going to be c. The third term of this would have been, the third term in this would have been a 1, then a x squared. And the only x squared terms that we have, all of them are x squared. Now you see how to put this stupid? It's supposed to be x squared. Right now I have minus 1 to the power x squared on 8. Right? I mean, we know that how it's supposed to be x squared afterwards. And if I'm not mistaken, the solution for this one would have been, Let me do it over. I think it was 3/8. I think. So let me go and do it over, right? So first term, I'm not caring about it. Second term, no. Third term is going to be minus a half into minus a half minus 1 into x cubed over 3 factorial. No, x cubed, x squared over 2 factorial. So we get in minus a half by minus 1.5. Check it out, without a doubt. Minus a half multiplied by minus 1 and 1/2 divided by 2 factorial, which is 2. Indeed, we get 3/8 x squared. So the answer is D. Alright, this is a repeat one. We're going to get S sub n, take away S sub m, which is C. 21 is also a repeat. That was 135. This is a repeat as well. 1 and 3 was the answer. The coefficient of x squared in the binomial 2. This is a repeat as well. D is the answer. This one was also a repeat, and I made a mistake in the last year paper where I didn't take away. It's x take away. So the 4x and the 4x cancels. The 5 remains, and we got e to the power 2x into 2x minus 1, I believe. Right? I want to say the answer for this was D, but let me do it over. X take away the function e to the 2x plus 4x minus 5 over the derivative of the function, which is 2e to the 2x plus 4, 2x e to the 2x plus 4x minus e to the 2x minus 4x plus 5, e to the 2x into 2x minus 1 plus 5 over 2e to the 2x plus 4. The answer is D. Alright, new question. The Maclaurin series expansion for sine x up to the term in x cubed is, I think, no, this is a repeat question. I believe this one was B, x minus x cubed over 6. Alright, so it is a repeat question. So using the Maclaurin series expansion, we are going to get x minus x cubed on 6 to be the expansion. The value of the term independent of x in the binomial expansion, I know this one was 12C4 because when we did the working, we got 12C8 in one of the previous questions, and 12C8 is equal to 12C4. Again, this is a repeat question. I don't know if it's 3/4 or 4/3, so let's do it over. 4a is equal to a over 1 minus a. Divide both sides by a. I'll get 4 is equal to a over 1 minus a. 4 minus 4a is equal to a. I'll have to divide by 4, so the answer in this is going to be 3/4. Right, when I move it around, no, I will divide by 4. 4 minus 4a is equal to a. Move the a across. 4 is equal to 5a. A is 4/5. No. A over 1 minus r. Oh, this is going to be 1 on top. My bad. Alright, so it's going to be is equal to 1. So move the 1, move the 4. 3 is equal to 4a, and 3/4 is equal to a. This one was a repeat question. We have to use the method of differences to figure out what this is, and then we will tend n to infinity. The third term in the expansion of this in ascending powers of x is, so let me check and see what the third term is going to be. We're going to have 2 to the power 6 plus 6c1, 2 to the power 5 minus x over 2 to the power 1 plus 6c2, 2 to the power 4, minus x over 2 to the power 2. So the third term, 1, 2, 3, it's going to be an x squared term. So it's either a or c. Let's check and see if it's a positive x squared or a negative x squared. This will be positive, this will be positive, and this squared will be positive. So it's a positive x squared, so the answer is C. The equation has one real root. I believe the root for this was 1.67 between 1 and 2. This question here, we established that this question did indeed have no correct answers because of the wording in the question. The correct answer for this would have been 225, I believe. All right, so in a case like this, they will award the marks once they notice that it is a mistake in the question. So we will say error, no correct answers. The correct answer is 225. This is a repeat question from one of the older years, and 18 would have been the answer. 3 factorial multiplied by 3. Number 33, 60 is the answer. We will either have to choose pick 3 from 5, which is 5 pick 3, or 5 ways to pick the first letter, 4 ways for the second, and 3 ways for the third. Alright, so this one, we have to make sure we add up the correct numbers from the Venn diagram. The probability that K occurs given that L is K intersect L over L. K intersect L is 0.2 and L is 0.5. 2/5 is 0.4. Which of the following statements is true? So this is one of the variations to the questions, right? We don't have the C being the answer. If this was a N over here, then C will be correct. I know this is not correct, this is not correct. I need to have N here for this to be correct. So the correct answer is D, and we could expand it out on C. The 3 by 3 matrix with determinant 14. If the matrix of cofactors A is this, then A inverse is, so A inverse is minus 1, is 1 over the determinant multiplied by the adjoint matrix, and the adjoint matrix is the matrix of cofactors transposed. So once I see 4 minus 14 minus 2, this row is the same thing. I'm not going to entertain it. So 4 minus 14. All right, so that not going to work. This not going to work. Now, the matrix of cofactors, it by default supposed to already incorporate the sign matrix where the diagonals, we will leave the signs on the diagonals unchanged, and this, and this diagonal will change the sign. That is already built into the matrix of cofactors. So the adjoint is going to be 4 minus 14, 2 as a row. 4 minus 14, 2. 3 minus 7 minus 5 as a row. And then 1, 7, 1, 7, 3 as a row. Now, I don't know. It's not looking like there's any mistake there, right? And the only matrix that is closest to this answer is A. So what I'm going to do, I'm going to check and see. Let's change the signs to see if they incorporated the sign matrix into the matrix of cofactors. All right? So that means these things remain unchanged. So I'm going to have 4 minus 7, 3. I'm going to have minus 2 and 1. This becomes 14. This becomes minus 3. This becomes 5. And this becomes minus 7. Let's check and see what the transpose of this matrix is. 4, 14 minus 2. None of them will conform to 4, 14 minus 2. What about minus 3, minus 7, and 5? Yeah. Minus 3, minus 7, and 5. None of them conform to it. So I'm going to say none of these answers are correct. 4 minus 14 minus 2, right? 3 minus 7 minus 5, right? 1, 7, 3. Now, I want to say that something happened in the scan and the leave out a minus 7 there. I want to say that. Alright, so I will put the answer for this as A. Yeah. Alright, moving on to number 37. The letters of the word irregular are to be arranged in a line. The number of possible arrangements in which the 3 R's are not together, I'm going to put the 3 R's together and see how much arrangements we're going to have. So with the 3 R's together, we're going to have, that is one block, right? So we're going to have 1, accounting the 3 R's as 1, that is 1, 2, 3, 4, 5, 6, 7. So 7 factorial is when the 3 R's are together. Do we have any repeats? I, E, G, U, L? No. So the number of ways in which we can arrange this with the R's are together is going to be the number of R's are not together is the total number of ways take away the number of ways where the R's are not together. So total number of ways is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9 factorial over, we have 3 numbers repeating, 3 factorial. Take away that. So the answer is B. 38. Alright, so same story again. They change the answer in the previous year and then they come back and they give you the same stupidness in this year. This has no accurate answers. The correct answer is 3/10. What's the probability that the product of 2 nodes prime? Yep, 3/10. If P is that, Q is that, and then PQ is that, the matrix P inverse equals. So PQ could be 21 into 1, 0, 0, 21 into the identity matrix. So PQ is 21 identity. So if we want to get P inverse, let me hit them with a Q inverse on both sides. If I Q inverse PQ is Q inverse 21I, now Q inverse by P by Q, I'm not too sure whether the matrix multiplication will facilitate this to be we want P inverse. Okay. Sorry. So P inverse on both sides, P inverse by PQ is 21I by P inverse. So P inverse P by Q, which is I by Q, which is Q, is 21 P inverse. So Q is 21 P inverse. So 1 over 21 by Q will give me the P inverse. A sample space of S consists of 3 mutually exclusive. This is a repeat question. 0.3, 0.6, and 0.1 will give me 1. This is also a lie. It's not a repeat. The general solution, this is a variables are separable. So we're going to have dy over y is equal to dx over x minus 2. ln y is ln x minus 2 plus I'm going to put ln c as my constant. So ln y is ln c into x minus 2. So y is equal to c multiplied by x minus 2 if possible. Okay, so this is one variation of the answer. It's not a variation that we would have gotten here. So let me check and see which variation we get in, right? Making sure I rearrange properly. You go down there, yes. So this line here is correct. ln y is equal to ln x minus 2. Let me see what we have in our solution, right? We want to get y. So if I put plus c over here and I exponentiate both sides, I'm going to get e to the power ln of x minus 2 plus c is equal to y. Do we have that? I can now break this up to make it look like e to the ln of x minus 2 multiplied by e to the c is equal to y. Do we have that? E to the ln x minus 2 multiplied by e to the c is y. So the answer is B. These are 42 and 43 are repeat questions. The cofactor of x may correctly be written as, so u and u go away. It will be 1 minus 1 2 minus 1 2, right, and minus 2 0. Good, but this particular entry will have a minus in front of it, so the answer is D. And m is singular when x has a value of, so bringing across the working for the determinant of the matrix M from the previous year, we will get the determinant to be minus 1 minus 4x. For a singular matrix, the determinant is equal to 0. So when we solve, we get x to be minus a quarter. Given that pi on 4.5 is the solution for this, so we would get 1 on cosine squared, which is sec squared, and I integrate, I get tan. So the answer for this is A. This is also a repeat question. We have real and equal roots. So the general solution for this one would have been ax plus b e to the power of the solution, that is x plus 3, so minus 3x. And when y is equal to, when x is 0 and y is 0, 0 is equal to a by 0 is 0 plus b, I'm multiplying out one time, right? B e to the minus, b e to the 0. So I'm going to get b is 0. So when b is 0, I'm going to get ax e to the minus 3x. B corresponds to that because at the end of the day, a and b are constants. And that's it for 2023.